Hello students, in the last project, we learned about the overall structure, basic types, and engine performance and design indicators of aircraft engines. In this course, we will study the engine components. Aircraft engines are composed of 5 main components. In this project, we will first study the compressor components. First, let FCU review what the compressor does. The main function of the compressor is to increase the pressure of the air entering the engine and supply the compressed air required for the engine to work. In addition, the compressor also has the functions of pressurizing the cabin and cooling the turbine components. Next, let these learn about the performance indicators of the compressor. The main indicators of compressor performance include compression ratio, efficiency, overall dimensions and weight, and working reliability. We have already learned about the compression ratio of the compressor. It refers to the ratio of the total pressure at the compressor outlet to the total pressure at the compressor inlet. The efficiency of the compressor refers to the ratio of the actual work of the compressor to the ideal work. The larger the ratio, the higher the efficiency of the compressor. The overall dimensions of the compressor represent the mass flow of air flowing through the engine per unit area, so it is also one of the important indicators of the compressor. As for the working reliability of the compressor, we certainly hope that it is as reliable as possible. The greater the reliability, the lower the failure rate of the compressor. Next, let these take a look at the design requirements for compressor components. First, the performance of the compressor should be stable and have a wide stable operating range. Second, the compressor structure should have sufficient strength and appropriate rigidity. Third, it should work reliably and have a long service life. Fourth, it should be small in size and light in weight. Fifth, it should be easy to maintain and detect. Sixth, it should have a high performance to manufacturing cost ratio. Compressors can be divided into centrifugal compressors, axial flow compressors, and hybrid compressors, according to the flow of air. As shown in the figure, the first picture is a centrifugal compressor, the second picture is an axial flow compressor, and the third picture is a hybrid compressor. The hybrid compressor is composed of several stages of axial flow compressors and one stage of centrifugal compressor. Next, let these learn about centrifugal compressors. Centrifugal compressors are generally composed of an air intake device, an impeller, a diffuser, and an air collector. The airflow in the centrifugal compressor flows in a direction away from the rotation center of the impeller. Centrifugal compressors generally have the advantages of simple structure, reliable operation, a wide, stable operating range, and a high single-stage compression ratio. However, centrifugal compressors have a large frontal area, and it is difficult to obtain a higher total compression ratio, so they are generally used in small power units on trainer, aircraft, missiles, target aircraft, and aircraft auxiliary power units. Axial flow compressors are generally composed of rotors and stators. The airflow in the working impeller of the axial flow compressor basically flows along the axis of the engine. Axial flow compressors generally have the advantages of high total compression ratio, high efficiency, large air mass flow per unit area, and small wind resistance. Therefore, axial flow compressors are used in aviation gas turbine engines, especially in medium and large thrust engines. Therefore, in this project, we focus on learning the structure of axial flow compressors. An axial flow compressor is generally composed of a rotor and a stator. The rotor is the rotating component in the compressor and is generally composed of rotor blades, a disc, a drum, a shaft, and connecting parts. The rotating blades do work on the airflow to increase the pressure of the airflow. The stator is the stationary component in the compressor and is generally composed of a casing and stator blades. Next, let these learn about the two structural features of the axial flow compressor. The first feature is that the meridian channel of the axial flow compressor is convergent. What is the meridian channel of the compressor? The meridian channel of the axial flow compressor is a channel formed by the casing and the drum. In line with the convergent channel of the multi-stage axial flow compressor, the blades of each stage of the compressor have the characteristics of gradually decreasing blade height, gradually shortening blade chord length, and increasing number of blades. The second characteristic of the axial flow compressor is that the axial flow compressor rotor blade channel is expanded, and the axial flow compressor stator blade channel is also expanded. Students, can we think about why their blade channels are made to be expanded? The reason is that the supercharging principle adopted by the axial flow compressor is diffusion supercharging. According to the flow continuity equation and Bernoulli equation, when the airflow flows through the compressor rotor blade channel, since the rotor blade channel is expanded, the relative speed of the airflow decreases and the pressure increases. When the airflow flows through the stator blade channel, since the stator blade channel is also expanded, the absolute speed of the airflow decreases and the pressure increases. In this way, after the airflow passes through the multi-stage compressor, the pressure will increase a lot. This is the principle of diffusion supercharging of the axial flow compressor. Students, in this class, we have learned about the functions, performance indicators, design requirements, and classification of compressor components. Through this class, students must master the functions, components, and working principles of axial flow compressors. Thank you, everyone.